So, hello everyone. My name is Mandar, and today I'm going to present a topic implementing low-code CQRS with Azure Logic Apps. So, a little bit about me. My name is Mandar, and I currently work as a business integration architecture manager. That's a fancy name for a architect, and I currently work with Accenture India. And in my day-to-day activities, I'm mostly responsible for architecting applications on Azure as well as Power Platform. I'm a certified architect. Plus, in my spare time, I'm a continuous delivery enthusiast and I like to read and talk about Azure and Power Platform in general. Right? So, if you want to connect with me, you can email me on kodidharma@gmail.com, or you can connect with me on LinkedIn or tag me on Twitter. So quickly moving into the agenda for today, I quickly want to talk about the traditional CRUD based architecture and where it fails. And then we'll look at what exactly is a CQRS and how it can help us solve the problems that a traditional CRUD based architecture has. Then I'll do a quick demo of a CRUD API, how we build it using Azure Logic App. And then we'll see how we re-architect that into a CQRS based architecture and see what advantages and disadvantages it brings. And then we'll take a few questions if the forum has any. Right? So if we take a look at the traditional CRUD based architecture, on the left hand side, if you see, I have a very high level model of how uh, application works, right? And you might look at it as a 3-tier architecture wherein you have a presentation layer, application or business logic layer, and then you have your database in the backend, right? So in a traditional CRUD based architecture, what happens is your UI internally communicates with a set of CRUD APIs. CRUD APIs being create, read, update, and delete operations, and it performs those kind of operations on certain resources. So, for example, if I'm talking about Amazon website, a CRUD operation can be thought of as placing an order, right? So, in that case, for your order resource, you would have CRUD operations like creating order, reading order, updating order, or deleting order, right? So, uh, all of that happens through a set of verbs like get, post, put, and delete, right? And what happens is you only have one application layer wherein whenever the front end introduces a particular call, say to create order or to update order, what happens is your UI then calls the API layer wherein you have some sort of business logic validations, etc. defined. And once the given data passes that, you then basically create or update a resource in the backend database. And on the other hand, you have read operation like reading a set of orders for your personal account, or maybe reading a very specific order using ID. So in that case, again, what happens is your UI makes a call to the order resource, and then the call goes through your business logic layer and then communicates with the same database that sits in the backend. So in all the cases, in all the operations that we have, the create, read, the update, and the delete, everything that we do for a particular resource happens on the same database, right? So you have a same database and same table wherein you are interacting with one particular uh, resource. So this is your traditional CRUD based architecture, and in your UI you would have multiple resources. Like if I talk about online shopping, so you would have resources like a order, a payment, a basket, a cart, right? And each of it would have different CRUD APIs which interact with the different uh, tables in the backend. But the general idea is, in the CRUD world, all the either you're creating or rather the commands which are creating, updating, or deleting, and the queries, which is basically your read side, happens on the same table and on the same database in the backend. Now, this scenario is best for 99% of the use cases that you would build. And again, this is something that I've experienced, that CRUD API solve the architecture problem for 99% of the problems. Now, why CRUD might fail? So one might ask, if 99% of the problems are solved, why would CRUD fail, or why would I need an alternative kind of architecture, right? So let's take a example of an insurance system. So when you are creating a quote, let's say you are on a policy bazaar and you are creating an insurance quote for, say, life insurance, right? Now, when you are creating it, you are actually filling out details like your personal details, your name, email address, date of birth. Then you fill out your health history, you fill out your past uh, health history, right? And then you fill out other details like what kind of coverages you need and all. So now, if you look at this entire quoting process actually spans across multiple tables. So you would have a quote table, you would have a applicant table, you would have a health history table, and multiple tables. So when you create a quote, what happens is you are actually executing a complex transactions across multiple tables. Now, when you want to retrieve the same code from the different table, the problem is that you have to write complex join across multiple tables to get value for one code, because the if you look at the insurance code, it is a highly relational in nature, wherein the code is related to your applicant details, your health history, your coverage details, premiums generated, so on and so forth, right? So every time you want to run a query for creating a code or reading the code, the if you keep it in the same context or in the same API layer, then it becomes difficult to maintain that logic, right? So there, CRUD APIs might fall short. The other area where the CRUD APIs might fall short is when there is a different scaling between the read and write sides. Now take an example of the social medias. So in your social media, your read side scales more faster as compared to your right side, because in social media apps you are consuming content or the post feed which contains different posts aggregated from different users, which is tailored to you, right? So your social media app is making multiple get requests, or the backend API is pushing multiple get pushes to your app, right? In that case, your read side is the read side actually requires a heavy scaling, but if you look at the right side, you would be creating maybe one or two posts maybe every 2 or 3 hours, or depending upon how active you are on social media, right? So there is a difference between scaling requirements for your read and write. In that case, having a same database causes problems, because if you use the same database, then you have to share resources between read and write operations, and then in that case some uh, problems might occur due to the resource contention, right? So in that case, CRUD APIs might fall short. Then the third example is when you are actually building microservices and you have multiple contexts and services. For example, in case of a uh, shopping cart, you would have different microservices for order processing, you would have a different microservice for payment, inventory, right? So if you want to create a query which span across all, or rather gathers details across all these three different services, then in microservice world you cannot actually directly query the database as we saw in the insurance quote example. In that case, you actually need to call the get endpoints of the individual services to get the data and create a aggregate view for whatever you want to show, right? And another way is to rely on to asynchronous event based communication, which I will discuss in our demo section. So point being, even in such case where your queries span multiple contexts and services, then you would face problem with CRUD, because different services again would be calling different get queries for a different number of times, right? So when at a very high level, if there is a queries requirement is different than your reads requirement, generally we go for a different kind of architecture. So that brings us to the question, what is CQRS? So CQRS stands for command and query responsibility segregation, right? So now let's take the example of the order service, right, which we discussed initially. So in your order service, if we take a look at the CRUD operations, you would have your create, update, and delete as the commands, which actually alter something in your database table, which which we call produces side effect, right? And then you have your get side, which is basically querying the data from the database. So your C, U, and D is something that produces a side effect, and your R is something that just retrieves some state from the database, right? So CQRS, what it does is it talks about segregating these two out, right? So as you see in the in this particular diagram on the left hand side, the application model is now broken down into command model and the query model. And the advantage we get with that is that we can now actually have different databases in the backend and have different domain logic or business logic for your query model and command model. And we can scale them independently, right? So that's how your CQRS comes into picture. Now, the advanced form of CQRS is, even though the diagram shows a single database here, you can implement multiple databases or multiple tables, and you can synchronize the data between your command and query. Right? So let's take a look at a quick demo, and I think that will make us understand CQRS practically. Right. So let me first of all bring up the CRUD based API architecture, right? So I'm going to work with a catalog service. For this demo, I have picked up a example. So we all have heard of this online game called PUBG, right? Or there are other multiple online games wherein millions of people play at the same time. So their scaling becomes really important. So in PUBG or in online games, generally you have a ability to purchase some sort of maybe guns or any other instruments which boosts your performance in the game, right? So let's call that uh, service which gives you details about all these instruments and other health packs and all that you can purchase, a catalog service, right? So the following architecture shows you the CRUD based implementation of it. So you would have a catalog container in your Cosmos DB, which contains all the products that are available for players to purchase from in a particular country. And then you would have operations like adding new items to the catalog, or updating an existing item, or deleting an existing item. And then you would have a get catalog item. Now, if you try to correlate this with the uh, limitation, or rather the requirement, we will see that the create, update, and delete is far less frequently run as compared to the get method, right? Because millions of player would be accessing this get endpoint to load the list of products that they can purchase in game and try to purchase them, right? But the create, update, and delete is something that is rarely run, and that too by the backend operations team to introduce uh, a new product into the catalog, right? So how this translates into your logic app is basically you would have individual logic apps which would deal with single responsibilities, right? So you would have a logic app which can create a item into the catalog container. You would have a logic app which can get the ID and update the particular item, or you can use the ID just to delete the item from the container. And then you would have the ability to get a particular item using that ID, or you can get the entire list of products that are available in the country, right? So let's quickly take a look at how this can be implemented in Azure. So let me, so I have this date Azure Cosmos DB called Fantasy Gaming. And if you take a look at the containers, I have multiple containers here, but in the real life, you can apply the same principle and have multiple Cosmos DBs to do different things, right? So here you would have, we have a container called as catalog CRUD, on which I'm doing all the 4 operations that I just showed you in the architecture previously, right? So your create, read, update, and delete all happens on the items that are inside the catalog container, right? So how that happens, let's quickly take a look at a simple logic app, which basically creates an item in the catalog service, right? It is just 3 steps. You get a request. Again, it's a demo, right? Your real life logic app would be quite complex with exception handling and all. So you basically take detail like country, description, price, and name of the item, and you add a catalog item to the this collection called as catalog CRUD, right? And then you send back the response. So if we try to run that in Postman, the request would look something like this, right? So let's say we are updating all the item, or rather the color partition for India, right? So let's say I want to add a product called as Silver Shield, and let's say it increases the defense of a player by 1.5, and the price for it is 1.8. So if we send this, you'll see that the logic app returns me the item ID, right? And if we take a look at the container, here you'll see that the CRUD container actually has a new entry, which let it load. Yeah, Silver Shield. Yeah, the one that we created, right? Now, at the same time, we can have a different logic app to update the. Hold on, let me apply the filter. So we can have another logic app which updates the same CRUD database. Right? So again, this logic app is also simple. It takes details like the item ID, country, description, name, and price, and it replaces the document that we just created inside the catalog CRUD container with the new details that we pass, right? So if we look at how it works, so we'll just copy paste this, what we added. If you take a look at the body of this, you'll see that I'm passing the item ID that is required for the update. Right. Apart from that, what I will do is I'll just replace all these and let's just change the value to 3. Right. Yeah. So it has successfully updated because we got 204 no content. Now let's take a look at this again. So let me open the items. Yeah, you'll see that the price has been updated. So uh, that's how it works, right? Then there is a simple, or rather there are two logic apps which work with your uh, read side. Those are you get your item by the ID. So you would have a logic app which, okay, let it load. Yeah, so you would have a logic app which contains the path like the country from where you want to query the catalog service, and then the item ID, right? So and then what it does is it basically goes to your the same database. So take a look at this, right? So we are updating and reading from the same collection ID, that is catalog CRUD, and then we basically say whether the response is successful or not. If the response is successful, you send back the details like the country description and whatever data is stored, or in case of exception, you return whatever exception occurred. So if we try to get this item by ID, you'll see that I'm passing the country as India and the item ID as what we just created. So once we run this, you'll see that we get the response back, right? And it is the updated response. Same happens with get all catalog items, right? So it gets all the catalog items for a country rather than a specific ID, and it gives you back the response. And the delete operation is basically, as the name suggests, that you just pass the country and item ID and it removes it from the list. Now, the point being, all of these APIs that I showed you, the different logic apps that I just showed you, they are actually working on the same container, which is your catalog CRUD container. Right now, this is a small example, so the scaling might not be as visible to you as it is required. But when you do this in the real world, when there are millions of folks accessing this, then this becomes a problem, right? That you would have resource contention because every container or every database would have some sort of limitations, and then you'll also have to think about the billing that you might incur if you keep on scaling the same database again and again, right? So to uh, move away from that, what we do, as we discussed in the basics of CQRS, is that we create two different containers or two different databases, whatever the design be, and we call them, one is for storing the side effects of the command, which can store the results of your create, update, and delete. And then you have one container or database which stores the copy of what happens inside the CQRS, or rather the command side, right? So the way the architecture works for that is, let me quickly go back to the presentation mode, is it becomes a little complex now, right? So you have one container called as a catalog command container, wherein you would store whatever the create, update, or delete logic apps do, right? Basically creating a catalog item or updating it through ID or deleting it through ID. And then you would have a different container which stores a similar copy of what is happening inside the catalog command container, and then the read side actually reads from the other container or other database, right? So there are different patterns to before we go into that, the important thing that comes up here is that if we do not do anything, then the data that we create or update or delete inside this command container and the data that we have in query container will move out of sync if we do not have some sort of syncing mechanism, right? So one of the patterns to synchronize what each of these logic apps is creating a side effect, what we do is we publish an event of what this logic app did onto event grid topic, right? So for example, if a create logic app is creating an entry inside a catalog container, what we would do is that we would first create an entry inside the container or a database, and then on event grid we would raise an event called as item, or rather item created event, right? And then there is a synchronizer process or a logic app which subscribes to event posted on this event grid, and then what it does is whatever we have posted on the event grid, it goes and updates into the logic, sorry, the read side container. That way, whatever you are inserting into this gets synchronized into the container side, right? So what you have done here in principle is that you have segregated out the uh, right side, which includes your create, update, and delete, and you have segregated out your read side, which is basically getting the catalog item by IT or catalog item, the master list for a country, right? The advantage now we get is that we can independently scale the read side as well as the write side, right? Since in theory we would, if we go with a different databases for this, we can have a different scaling model for this and a different scaling model for this as required, and that saves us a lot of money, right? And it creates, or rather solves the problem of the read and write scaling differences that we just saw initially, right? So that in theory is your CQRS. So you had the previous simple CRUD based API architecture, 4 different logic apps talking to your same container or a database, and you broke it down into the CQRS pattern by separating out the create, updates, and deletes and the read side, right? The only downside, not the only one, but the downside, as you can see, is that you have to do some extra heavy lifting here, that you have to actually write some sort of synchronization logic, because if you don't, then the read side and the write side go out of sync and the data that you get might not be true at any point in time, right? So let's quickly take a look at how we can implement this in logic apps. So let me quickly change the filter here. So as you can see, I have here something called as a topic, event grid topic. So this event grid topic allows us to publish events onto this, right? And then any subscribers that are there that they want to listen to this particular kind of event, they can tap onto this particular event grid topic to subscribe to those events and react to them, right? So let's quickly take a look at this create logic app. So the initial logic app that we had only had 3 steps, right? You get the request, you insert it into a DB, and you send out the response. Now, if you take a look at this logic app, it goes one step further, right? So you are basically getting the request here. Then you are adding that detail. Now, look at the difference here, right? So we are adding it to the commands container. And then what we are saying is we are publishing an event. We are saying that catalog.item.created is my event, and I'm publishing whatever I'm inserting into my Cosmos DB. And there is a subject, right, which tells me that this is a particular event related to a catalog service. And then you would send out a response back to the caller. Right now, the advantage here is that we have done two things before sending out the response. We have added the item to the Cosmos DB, and we have published the event stating that, boss, this API has created an item inside this particular container or database, right? But the important thing to look at here is that the entry is created into a CQRS command store, right? Similarly, if we take a look at the update, it does pretty much the same thing, right? It takes the CRUD update that the CRUD version of update that we had, and introduces another action or another step to publish whatever we are doing inside the Cosmos DB, right? So in case of update, it would raise an event like catalog.item.updated, and similarly for the delete, you would have the same thing, right? That you would delete the document from Cosmos DB and then raise the event that catalog.item is deleted, right? So you're deleting a document first and then raising an event like this, which is basically your data that you are passing. Event type is catalog.item.deleted and the subject, right? Now before taking a look at the read side, let's take a look at this synchronizer process that we just saw earlier, right? So if you take a look at the logic app, you'll see that it is actually tapping onto the event, uh, this particular event grid topic that I just showed you previously, right? So what it is doing is it is actually looking for events where the subject line contains something like this, right? So you can have different synchronizers for different services, right? So this one particularly works only for the catalog service. So if you have a payment service, you can have a different synchronizer wherein your prefix filter changes from catalog to payment. Or if you have something called as a order processing, there you would have a different filter, right? And then you have a simple filter type which says that for my event type, if the uh, event is catalog.item.created, I'm basically going to the query side. Now here is the difference, right? Now I'm updating the query container with the data that was published onto the event grid, right? So the the create side, the update side, the delete side, whatever they did it in the Cosmos DB and published the same set of data onto the event grid topic. Now this synchronizer reads the event data that was published and inserts that into the query container or a query database. And same thing happens here for your item deleted, wherein you would delete the item, or in case of item updated, you would update the item, right? So this process synchronizes the entire, or synchronizes the changes in the CQRS, or rather the command side with the query side. Now, let me quickly show you how this looks, right? So if you take a look at this, again, create catalog item, here you would have a similar request, right? On the front end, nothing looks different, right? I'm passing details like my country, uh, the name, description. So let me just add fake health potion, right? So if I just do this, if we send this, you'll see that I got back the item ID right now. But let's see what happens here. You'll see that if I go to the run history of this, you'll see that there is this particular event that just got, or rather this particular synchronization instance got triggered. So if you can see that when, okay, let me open another uh, instance here. Let's look at the create side first. So yeah. So if we go to the run history, you'll see that at 2:05, I triggered a request here wherein I passed details like your country, India, the name, ultimate health portion, basically what we send from here, right? Same thing. And what this API did is that it inserted into the Cosmos DB, and then it published the event onto the event grid topic with the same details, right? Whatever it received in the request. So let's correlate this with the synchronizer now. So the synchronizer was actually listening onto the event of that topic. It picked it up. It said that, yes, this is item created. So I need to go and update, create this document inside the Cosmos DB. Right. So here you'll see that uh, if we go to the command side, there should be a new entry here. So ultimate health portion that we created right now. If we go to the query side, the synchronizer created the same entry into the query side. So let me see, where is it? Should be here. Hold on, let me check what is the ID for this. 4076. Okay. Yeah. So it's here, right? So this is how the synchronization happens. Now let's run another. So let's now run the get catalog item by ID, right? So this is something that happens now. So if I run this, you'll see that I again get back the response like this, the ultimate health potion price and all. So what happens on the read side now? So let's open the read side logic app. So if you see here, okay, let me go to resource groups. All right, so get item. Right. So if you check this logic app, you'll see that this is actually reading it from the query database, right? So whatever your side effects that the create or update or delete had, those got synchronized into the query container or query database, and then the read side is actually reading from that particular different database, right? So herein lies the beauty of CQRS, that as we saw, the C and the U and the D might not be that, or we might not require a huge scale on that, right? So what we can do is we can have different container or a different database for it and have different scaling mechanism for it or scaling parameters, while the query side, which requires or rather requires millions of requests maybe every 10 minutes or 20 minutes or so, you can have a completely different Cosmos DB database and have dedicated scaling for that, right? So that's how your uh, read side and the write side are segregated, and you basically have this uh, highly scalable kind of architecture, right? So uh, but uh, everything is not as golden as it looks, right? So let's take a quick look at the advantages and disadvantages of CQRS. So the advantage is that it allows us to scale the read and write sides separately as required, so that we can better manage the performance of the app, as well as we can better manage the billing that we are incurring, right? Now the other side is, now if you're talking about the relational database, so we just saw the example from a Cosmos DB side, but if you're talking about a relational database like Azure SQL, then segregating your read and writes to different databases can allow you to have optimized schemas which are better suited for reading and writing as required, right? So the segregation allows you to optimize your schemas as well. Then the third is, as we saw with the synchronizer approach in the backend, uh, if you have a service which actually needs to go to different tables or different bounded context services and gather data from there to create a read side view, then in that case, segregating it out and tapping onto the events style of architecture that we just saw using event grid, that makes the uh, query aggregation simpler, right? And the other advantage is that separation of read and write can make the application easier to maintain, right? So that is from a more from a development perspective, right? So these are the advantages, but the disadvantages are also glaring, right? So this is why I said that 99% of the time you can get by with using CRUD, but the disadvantages of CQRS is that the basic idea of CQRS is deceptively simple, right? All we are saying is, yes, separate out the read side and separate out the your command side, right? And yeah, we are done. But it is not that simple. As you saw, whenever you introduce this concept of asynchronous programming through event grids or messaging bus and topics and all, then your application, even though it is easier to maintain, it becomes highly distributed in nature, and it becomes difficult to visualize, and you have to introduce a lot of observability and telemetry and all those kind of logging logging mechanisms to basically have a better observable application, right? So even though it is simple, the maintenance that we have to set up around CQRS implementation is not that simple, right? Now the second one is, as we saw, that when we are separating the reads and writes, it is necessary that the changes in the write side are synchronized to the read side, which is generally accomplished using asynchronous messaging. Now this actually leads to this concept of eventual consistency. Now here, since we are using Azure event grid, the consistency is almost real time, right? But there is still a delay of few milliseconds between what we write to the command store and what gets put into the query store, right? So your databases are not updated in real time. That is one thing that you need to understand before implementing this pattern. The eventual consistency basically means that your read and writes will be eventually consistent. Now, if you are using, instead of event grid, you are using Azure Service Bus, then in that case, your databases will be consistent after a slight delay because you are using messaging there, right? But if you're using Azure Event Grid, then it becomes consistent in almost real time. But the concept is still the same, that when you are separating out the reads and write, you will not get the updated data in real time, right? You will have to wait few milliseconds, few minutes, depending upon the infrastructure that you have, to actually get the read side up to the mark, right? And this is a problem because this is not suited for all the applications, right? So for example, consider this uh, catalog service, right? I mean, here CQRS makes sense because we are not adding multiple catalog items every time, right? It happens rarely, and that's why having reads and writes separated makes sense here, because backend operation can team add catalog items late at night, and then within few minutes, based upon the architecture, it becomes available on the read side, right? But consider an application like a stocks trading platform. There you need to have a real-time consistency of data. Whatever you are seeing in the market, whatever order you are putting, right, every milliseconds matter there if you are going into the algo style of trading. So there CQRS does not make sense. So as I said, CQRS, even though it is deceptively simple concept, we actually need to evaluate it based on a use case by use case basis, so as to make a particular informed decision whether we want to go into CQRS or not, right? So what I just showed you is the basic idea of CQRS, right? And then CQRS then continues to build upon it through the concepts of domain driven design and microservices and something called as event sourcing, wherein instead of a database you have an event store, wherein every event that we just saw initially, like the item created, item updated, or item deleted, are stored as a set of append logs, right? And you actually tap onto that. So that CQRS implementation with event sourcing becomes way more complicated than the simple idea that we just saw, right? So the basic suggestion here is that if you plan on using this approach in your application, just be mindful of the fact that even though the approach is simple, there are certain things that you have to evaluate, right? uh, I think with that, uh, I'll stop and I'll wait for some questions now.